There's really a couple main reasons why collisions aren't always going to result in a reaction. The first is that there's just not enough energy. A good example of this is if you're thinking about a reaction that takes an extreme amount of energy. For example, nuclear fusion or nuclear fission. When my atoms in my hand collide with a table or chair on a daily basis, they don't undergo nuclear fusion. That would be incredible if they could, and very problematic for humans. But the reason for that is there just simply isn't enough energy in them to undergo those processes. In this case, that energy is heat that's lacking. The center of the sun, on the other hand, does indeed have all that heat that's needed. The second thing that you're going to have contributing here is orientation, because, well, nuclear chemistry is a fascinating and very different example. But in the vast majority of chemical reactions, if you take something, say a molecule of water, and I decide, hey, I want to crash this molecule of water into, I don't know, let's say another molecule of water. And I do it at incredibly high energy, and I want to fuse them together. I want to make some fancy new compound. I'm going to call it O2H4. I don't know. This compound doesn't actually exist as far as I'm aware. We're just making it up for the purposes of this example. But if I go ahead and I try to collide them in an incorrect way, such that maybe I'm moving the oxygen over here to attack this hydrogen and try to form a bond here, this hydrogen is physically incapable of forming a bond due to the fact that it's completely oriented incorrectly. So if I go ahead and select these guys, and if I say rotate this around, oh, now all of a sudden there's going to be nothing that's going to be possible here. And obviously, this doesn't exist in our little makeshift compound that we've invented for the purpose of illustration. But there are many compounds that, if you try to react them and you haven't oriented things properly, they simply aren't going to react. And the rate constants that we talk about and work with are our best way of measuring the chance that they're going to turn out in the appropriate orientation.